Okay, the prime factorization method is a little similar to, well, involves similar setup technique. What we do with it's a little differently, but let me give us two numbers, something that we can't see in our heads. So 2,520 and 10,530. So something just really big. Okay. And so I'm going to do a factor tree and see what goes into what. Say I know 2520, I can take out a 2, and then 2 and 1260. And then I can take out another 2, and then, I'm sorry, 630. Looks like I can take out another 2, 315. Okay. And then I'm going to ask myself, does 3 go in there? And let's see, so if I add up the digits, so 3 plus 1 plus 5 is 9, so 3 definitely goes in there. And that would be 105. And let's see, can I take another 3 out? Let's see, so 1 plus 5 is 6, so yeah, 3 goes in there. And 35, okay, well 35 is 5 and 7, so we're good there. Okay, so let me go back up. I have 2 cubed times 3 squared times 5 times 7. And I'm actually going to write out, I'm going to put it in its exponent form for this one. And then let's do the same thing to 10,530. So I know 2 goes in there 5,265 times. And then I run out of 2's. Well, that's nice. Let's see, does 3 go in there? 10, 18, 18, 1 and 8. Okay, yeah, 3 goes in. 1,755. Let's see, is it worth it to do another 3? 1 plus 7 is 8, plus the 2 5s gives me 18. So that's divisible by 3. So I definitely can take another 3 out. All right. Oh, wow. There's another 3 goes in there because that's still 18. So that's 195. A lot of 3's in this one. Let's see, 195 is 19. So yay, now I know that 3 does not go in. So then I want the next prime number up is 5, and I know 5 definitely goes in there. 39 times. And let's see, 39, I believe, is divisible by 7. No, it's not. 39, we can take another 3 out. Wow. I missed, oh, I did, okay, wow. Okay, so we got 3 and 13. No, it's not. Yeah, 3 and 13. Okay. Okay, so let's collect up all these numbers. I have 2 times 3 to the 4th times 5 times 13. Okay, let me go back up here. All right, so the LCM, the least common multiple of these two numbers, this is how this technique works, is I'm just going to make a list of all the factors, and it has to be, so the LCM is going to be, it has to have that number of 2's in it, that same number of 3's that has them, okay, explaining this all weird here. All right, so 2,520 has 2 cubed in it, so I know the LCM has to have at least 2 to the 3rd power, and the 10,530 has a 2 in it, so having 2 to the 3rd, in other words, I can't have any less than the number of factors. I can't have more, but I have to have at least 2 to the 3rd, and 2 is definitely in 2 to the 3rd, so that's part of the LCM. Then I go to the 3's, and I know I have to have, let's see, 3 squared, but I have 3 to the 4th, that's bigger. So it has to have 3 to the 4th in it. I know it's going to have a 5 in it. It's going to have a 7. It's going to have a 13. Okay, so that is the prime factorization for the least common multiple of those two numbers. And so at that point, I just multiply that out, and I don't think it's a bad idea at all to get a calculator out for something that large. And so if you hit the buttons in the calculator, you get 294,840 would be the least common multiple of those two numbers. Okay, so this next method is called the GCD LCM product method. Let's set this up with a list of factors and sort of an interesting little connection we make. Okay, so what is the prime factorization of 24? So 24 I can break up as to 2 and 12, and that's 2 and 6, and that's 2 and 3. All right, so I have 2 cubed times 3. 30 I can break up as to 2 and 15, and that's 3 and 5. So 2 times 3 times 5. Okay. Now I'm going to do a Venn diagram here, and you'll kind of hopefully see where I'm going with this. So I'm going to set it up to be prime factors of 24 and prime factors of 30. Okay. So in that list of factors, what numbers do they have in common? Well, they both have a 2 and a 3, so they both have that, and they both have at least one 2, so 2 and 3. What else does 30 have that 24 doesn't? That would be 5, so 2 times 3 times 5 gives me 30, that's true. What about 24? Well, 24 we have that 2 cubed, we already used one of it, so we have 2 other 2's. Okay, so the GCD of 24 and 30 we would get by looking at that middle region. So that's 2 times 3, which is 6. The LCM we get by collecting up all of the numbers. So that would be, has to have at least 2 cubed in it, has to have at least a 3 in it, and has to have a 5 in it. Okay, so if we multiply that all out, we get, let's see, 2 cubed is 8 times 15. All right, so we get 120 as the least common multiple of those two numbers. Now, something interesting happens. If I take the GCD of 24 and 30 times the LCM of 24 and 30, we're going to get something interesting. So let's take 6 times 120, which is 720. Okay, now take a look at 24 times 30 though. Take a look at the original two numbers. 24 times 30 is also 720. Now think about that for just a second. I've got this nice pretty relationship between the GCD and the LCM and the product of the original two numbers, and I can actually use that to speed up the process for finding one of the three ideas. Okay, so that gives us this nice lovely formula. So let's say I've got two numbers A and B, so the product of A times B is the same as the product of the GCD of A and B and the LCM of A and B. Okay, so if I've got some really big numbers and I don't necessarily, one strategy I can do is instead of calculating the LCM directly, I can instead calculate the GCD and then just multiply the two numbers and divide. Okay, so let me give us two numbers that we can do this on. So I want to find the LCM of 731 and 952. Okay, already kind of on the big side, and I want to sort of speed this process up. So let me start by finding the GCD of 731 and 952. What do they have in common? Okay, well, let's see. I know 2 does not go into 731. If I add up the digits of 731, oh, let's not do this. Let's do the other approach. Let's do the Euclidean algorithm on that. So 731 into 952. It goes in there one time. And if I subtract, I get 1, 2, 2, so 221. And then I want to divide that remainder. So I want 221 to go into 731. Oh, let's see. 1 is not enough. Maybe 3 gives me 663. So then I subtract off 731 from the 663 and I get 68. And 68 goes into 221. Let's see. Well, 5. Let's see. 7. This rounds to 70. So 70, about 3 times, I'd imagine. Yeah, because 4 times puts it closer to 280. All right, so that's 204. And when I subtract that, I get 17. We're getting closer. All right, so I'm sorry, positive 17. So then I want to take 17 into 68. And that actually goes in there evenly. Yay. It's got a remainder of 0. Okay. Now, do you remember how to read this? What is the GCD then of this? It was the last number that I divided in, and that was 17. Okay. So what I can do with this observation then is I can take the product of the two numbers. So 731 times 952 is going to equal 17 times the LCM of those two numbers. And that's what I want, is the LCM. So if I take this basic algebra equation, I can take the product, 731 times 952, divide that by 17, and that should give me the LCM of those two numbers. And I'm definitely using a calculator for this. And I get 41,151 would be the LCM of those two.